Okay, here we have a Barina Astra ECU. Same thing, Vetra, whatever. I'll just run the scaffold blade down here and get some of the top layer of the goop off. It's not really necessary, but I'd just like to see where the start and end points are. Just using a Swan Morgan scaffold blade for that. That's obviously the closest one I had to hand. Right, grab out the big hammer and bladed screwdriver. Sometimes these easily come out, and sometimes not. So, a little tappity tap tap tap. Yep. And a little bit more. Okay. This one here has been a little bit more difficult compared to other ones. I do try to open them up the easiest way possible. And this one just isn't budging. Alright, there's more plans. This one still not opening up, that's okay. Nice little indentation there that I've got, so that's a good start point to choose a smaller, thinner spudger. Still not getting underneath that main seal. Nope. Okay. Second step. Dremel time. Okay, so basically we just made a deep crevice, we should say, into the aluminium, just to get our screwdriver in there, and then we can just break that seal. And we just need to work our way all the way around. Try not to deform the sheet metal plate, because we'll be using that later on. Other versions of these Astra ECUs, it doesn't matter if we deform them. In fact, yeah, it really doesn't matter, because they'll replace it with a laser cut acrylic sheet anyway, so that's not a problem. But for these ones, I do prefer to use the original plate. So just work your way around and just lifting that plate up, breaking that seal. Obviously not to drag the screwdriver inside too much, as you'll see what's inside. And there we go. Almost done. There we have it. Finally inside. clean up here. Look at that epoxy resin. Nasty stuff to get around the place, so just clean up that. And under we go. Okay, so let's have a look at these Y bonds, both sides, see if there's anything obvious. Now for the microscope time, you really can't see anything unless you've got a microscope. These bonds are looking pretty good so far. Just looking at the heels and see if there's any cracking. Okay, so let's look underneath the microscope camera and see what I'm actually seeing here, and we'll go from there. Okay, so here we are under the microscope, and we're just zooming in a wee bit here. We're going to tug just slightly on each wire bond with a pair of tweezers. You notice some connections are the same, like these two here, 4 here. Let's see those. They're under 2 tiers as well, so you're going to do the top ones and bottom ones. And just slowly going over each bond. There's no real easy way of actually testing these bonds apart from just giving them a tug, especially when that's the only failure that they really suffer from. There's actually these high mass wire bonds that fatigue. They just fracture and break off. So just carefully move across and tug each one. Also note if it's 3 layers deep, you do move across other bond wires and that they will touch each other. So just move them across with your tweezers and move on. So these are all looking pretty damn good. It's a slight tug each pull. This bank of 3 is connected together. Just methodically moving across and making sure you don't miss any. Got our grounds next. 4 grounds. So these would be the source for the injector drivers. Okay, these are all good. Moving on to the other side. We've got 2 plugs on this system, and just repeat the steps through. Carefully tug each one. Obviously, don't pull too hard, otherwise you'll prematurely break the wire bond. Notice how the group just moves out of position. So that's good stuff. I just move that one into a straight line again. And slowly move across. It doesn't take too much force. It is really obvious when they do break. And of course, any number of these can break. There could be multiple ones, not just 1 or 2. All controlling various systems. These are all looking pretty good. Nice grounds. Okay, so those are pretty good. Moving on to the these drivers here. These are the injector drivers. So you can see drain will be at the bottom of the base, and so gate, and that's their source. And got 4 of those, each for each cylinder. They look pretty good, no black spots. Moving on to the ignition ones, larger in package. They look pretty good too. Alright, moving on.
Okay, so looking at these drivers for the ignition, I've actually just soldered a little bit of a glob here of solder. That's to a direct path to the ground, so that will be the source current going through. If I actually go on to the microscope view, just for a second, I'll just show you where. Actually, I could just take a photograph of what I mean. So let me just do that. That's the wrong one. And get the microscope into a position and take a snap. There we go. Okay, so what I'm going to do is actually probe. I'm going to set up my multimeter probes and probe where the drain is on this system. So I'm guessing there. So I'm guessing about here will be one bank. Can't actually probe the base. Of these dies. Oh, here we go. This is one. There's 2. Okay. And the other 2 will be down here. Okay, so that's cool. So we've found the drain for the MOSFET. So basically you should have a current path going in. So this will be a NPN MOSFET. So this will be the what do you call it? The brain's gone blank at 7 o'clock at night. The source and the drain will be here, and then the gate will be here, and that will go to the microprocessor, which will probably be this puppy here. I'm guessing that this is flash memory. This might be I/O actually. Yeah, don't know. But anyways, so obviously with these sorts of ECUs, there is no chip numbers, and that makes it very difficult to obviously repair as well. So you can really only repair the wire bonds. Anyways, so what we'll do now is I'll just grab my scalpel. So I've made the link there, so I'm pretty satisfied that I can't do anything more with this unit. And I've done all I can with this system. So now it's time to glue it back together. Let's grab the hammer. Got a bit of deformed plate here, so I'll just smash that back into position. Bit of panel beating skills there. But beat there at 2. Okay, that looks relatively straight, as straight as it's going to get really. Providing that is the issue with the gate not driving. Hopefully it's not that. If it is, it's fucked. But if it's the source that it can't get, if it's the particular, well, it shouldn't be the drain, because otherwise you only have one cylinder misfiring. But the customer's experiencing all of them, so that's very unlikely. Right, what I'll do now is I'll just grab my chalking gun, which conveniently is sitting beside me. Because I did a ABS controller just before actually, so I'll fill this up with silicon. Chalking gun's worse for wear, Jesus. I think I need a new one. Bummer. Okay. Now just run around a bead of silicon around the entire perimeter. And let it cure over the night. Be ready for a pickup by the couriers in the morning. It's not like some of these cases where they actually have a huge, where they actually have an orientation. It just fits around either side. I might actually just fill in this part with silicon as well, where I've dropped the saw in. Because obviously if it does work, I do want it to last as long as possible. And it won't be helpful if water gets in when it is working, so that would just suck. Okay, it's all sealed up. I'll just put a press on that and it would cure quite nicely.